Make the fishes
All I know is that Braden and Lily get or become official in 22 days. So.
That's why they're sad. Like,
I was bored, good sir.
I just can't read.
Dude, they have to have like a party or something.
Why is that?
Yes, this is
We need
planned.
to have like a celebration, a
Yes.
get together,
Yes.
congrats party.
Yes, oh, that'd be amazing.
I have every single.
I think I'm gonna get a competition.
All right.
Yeah,
I mean,
we'll
I've
just
got the car.
What was your first
I'll make a
period?
sign.
history of architecture for some of us.
Stand in front of their house, just holding
Oh
it
yeah,
up.
All right.
one of those big cardstock.
Hey, we gotta switch our minds on the academic mode.
Yes, man.
Hoodie and jacket. Okay, so let's have a quick reality check here. Some of you did perfectly fine. You're on top of the material. Some of you literally are so far behind. I don't know how you're even going to possibly pass this year type worry. We need to get on track here really quick, right? Whatever happened, happened. Let's just fix things. If you didn't pay attention for the last two classes, you are so far behind. It is up to you to go on Teams and rewatch those classes, right? I'm not doing review, right? You made some choices, whether they were good choices or bad. You made some choices. You're going to live with those choices. We're having a quiz on Thursday on the stuff that includes 13.1 and 2. Well, technically it's 13.1, 2, and the algebra review as well,
I have
too.
to study for 2 classes? Yes.
Well, here's the problem, Seth, is that you had a 0 on the chapter 12 test,
True.
which dragged your grades so low that you're going to need to get super scores.
I know. I have a copied sheet of that.
All right.
I have 3. One's on my wall. One's on
And
my
he's not
desk,
the only
one's
one
on
who
my-
refused to take this test as well, too.
I turned mine in like a couple.
A couple days, and it wasn't very good, but yeah.
Hey,
But
I saw a couple formulas. I'm like, those look
put
right.
it down.
But I will say, for the people that showed up and put effort, they got A's. I mean, it was an easy test, right? It was just formula. It was just plug and chug, right? There were no surprises. There was nothing. I mean, obviously you can make a silly mistake, and some of you did, but I'm saying complexity like logic, usually that's the test that I get nearly all A's on, simply because it's literally the last 2 chapters. It's just plug and chug. Well, this chapter is not plug and chug. We're back to the regular geometry. Next Monday, although you will have class for me, that is a field day for periods 5, 6, 7, and student advisement. So this day right here, we'll do 13.7, but for lunch period, there is no period 5, 6, 7. We're gonna go to the park, eat lunch, and then play reindeer games or something like that.
Oh, heck yeah.
I'll be the reindeer. You can.
All right.
I'll be Santa.
Copy down your homework. Copy down your homework. Hey, we're gonna jump into this really hard today. I will just say this class, the way it's presented, is we won't do many examples. We're going to prove a couple things. The only good thing or the silver lining here is we're going to be proving something that you already learned in Algebra 1. So we're going to prove something that you may or may not recall from Algebra 1.
There's always a catch.
We didn't have it in Algebra 1.
Oh, did I have to write these down? I can't remember.
What if you consider like the failed trick side?
Make sure you write this down, Ethan.
No. Yeah, I already got all that down.
Okay.
Happy birthday.
All right, so it's 1 through 10 all. It's basically 2 ideas. Listen, please. 2 ideas. Big thing. Now, the issue is we're in a geometry class, so geometry is about proving things. We're going to focus on proving things. There are only, I think, 3 examples here. 1, 2. No, there's only 2 examples. Like literally like work that you're going to be asked to do. I'm going to give you 2 examples. The rest of the class is concentrating on proving things. So when I get to the very end and I say, hey, now look at your homework, look at the class exercises and pick something that you think looks complicated, make sure you choose wisely. And since Matt was the only one that showed up live every day,
True.
we did that a whole bunch.
I still didn't.
All right, so today's class is on parallel and perpendicular lines. And you're like, well, we've already done parallel. Yes, we've done parallel and perpendicular lines. Today's basically should be called the slope of parallel and perpendicular lines. All right, so these are very hard proofs, but they're really cool. And they're actually, once you see how it's done, you're like, okay, that makes sense. But they are hard. I would not ask you to do these by yourself. All right, altogether though, I would consider today a pretty easy day. It's two basic concepts. And I'm going to make sure when I get to that first concept, we're going to stop. You're all going to look at me and you're going to say, yes, I get the concept. Okay, here we go. So we're going to do 3 proofs today, 3 proofs. The chapter is called coordinate geometry. And here's the big picture, is that you kind of rip this finger out. So here's the idea, is that you take a shape and you put it on a graph. And then the mere act of putting on the graph gives us some information. Before, when we needed a proof, I would say something like, hey, this side is 10, this side is square root of 3. Now we're not going to get any of that. We're just going to get a shape, and we're going to ask to prove something on it. The way you do it is you put it on a graph, and the fact that it's on a graph, you'll be able to tell something. Okay? All right, this is a really slick proof, though, really slick proof. Okay, so the given is we have 2 lines, and that's it. Except that we're told that the slope of the 2 lines are equal to each other. We're asked to prove, now last year we said if the slopes are equal, then they're parallel. We never proved that in Algebra 1. That was just me telling you, or Miss Kittle telling you, that if the slopes are equal, then the lines are, literally we told you that. We never proved it to you. This year we prove it to you. We couldn't prove it last year because you didn't know what proof was. So here's the proof. I'm going to take the 2 parallel lines. Do we know whether the slopes are positive or negative? Do we know are they vertical or horizontal? Do we know anything about the slopes? No. How do you know that? This is the given. How do you know that? We don't. There's no way of knowing.
I know that there's 2 lines.
There's 2 lines, and we know their slopes are equal. Okay? I'm going to take those 2 lines, and I'm going to throw them on the graph.
And I guess the also given is that it lies on a plane.
Well, right. It's a line, so remember, lines live on the plane.
Yeah,
okay.
It's not like
They're coplanar. I agree. They have to be coplanar. It should say that, shouldn't it?
It should.
All right. I believe at the start of the chapter it says, assume everything is done on a plane.
Yeah.
Okay, so that's my given. And somehow, notice how small this is, because this is going to take some time. Somehow I'm going to get to proving that they're parallel. The issue with proving something parallel is we go to the definition. The definition says 2 lines that never intersect. Well, how do you prove that they don't intersect? Well, I have to prove that every single point on both lines are equidistant. This point from this point is 5, this point from this point is 5, this point from this one's, it would take infinity. You can't do it that way. Without coordinate geometry, this is almost an unprovable proof, right? But with coordinate geometry, it ends up being not too hard. Although I never thought of it. Some smart person than me thought of this proof, but it's pretty cool. All right, so here's how it's done. We're going to make, it's high school geometry, we're going to make triangles.
Yay.
Okay, so the triangle that I'm going to make, L1 is this one right here. I'm going to come off of L1 straight down to the x-axis, right? Straight down to the x-axis. So I just made what kind of triangle?
Right.
I made a right triangle. Why? Because I went straight down, right, vertically down to the horizontal axis. That makes a right triangle. The length of AB, whatever that length is, I'm going to keep that length and I'm going to place it somewhere so that it touches L2 once and the other end touches the x-axis.
And then you have to prove that there's a 90-degree angle and you prove the 2 lines parallel.
Yeah, but how do you prove they're parallel?
Are we gonna like do triangles?
We could, but once again, we get back to how do we prove things are parallel?
Great question.
And that's why I find this proof really cool because it's slick, right? All right, so the issue is how do you prove things are parallel? Well, we're going to go back to the definition. The definition says that their slopes are equal. Cadence was here for the last class, the last couple classes. She can remember things from algebra as well too, because she hasn't hit her head too many times, right? Unlike some of you. What's the definition of slope, Cadence?
The steepness of a line.
And we further define that as rise over run. We're going to use that definition right there to prove this one. We're going to prove that slopes are equal, and it's going to somehow get to parallel lines. You may or may not notice on your paper, I put a 1 and a 2 there. That would be an angle 1 and 2. And if I could somehow prove that angle 1 is congruent to angle 2 by the converse of two parallel lines cut by transversal, since they are corresponding, if I can show that angle 1 is congruent to angle 2, I am done. This one is a whole lot harder than what it looks like, but that's the basic idea. I'm going to show that angle 1 is congruent to angle 2. Now, many of you, Cadence was one of them, was like, hey, maybe we can show that two triangles are congruent or similar. Well, we don't know anything about their angles. Nothing, other than that they're right triangles. We know one A. We don't get the second A. We also don't know anything about their distances, so I can't get to a, SSS, SAS, anything like that. But we can use other things that we've learned in geometry. So let me get caught up where we're going. So where we're going to go is, I'm going to label where the red lines intersect the x-axis as points E and points F, right? E and F, okay? Now I'm going to go what we talked about with Cadence is, what's the definition of slope? And she said, what? Rise over run. So take a look at that triangle right there, AEB. What's its rise? What's its rise? What's its run? You said AB and EB. EB, yeah. So its rise is the distance of side AB. Its run is its distance of EB. And then for the other triangle, its rise is CD and its run is FD. So if their slopes are equal, then that must be true. And I apologize, it's really small, but I need that much space. So the rise over the run equals the rise over the run, and I'm giving it to you in side measurements now. Although I don't know what those numbers are, just a proportion. Okay? And that's just the definition of slope, right? And that was given that their slopes are equal. Remember what my goal here is. My goal is to say that angle 1 is congruent to angle 2. Then I can say two lines cut by transversal where corresponding angles are congruent, and the two lines must be parallel. That's my idea here. Well, I don't have that yet. I got to somehow show that the two angles are congruent, and I don't know what I'm going to do there. Well, actually, I do, but we're going to go back to trig. What's tangent? Remember the words? SOHCAHTOA. What's the tangent? Opposite over adjacent, which is also what you just did in the previous step. It's rise over run. Tangent is the rise over run. Tangent is the slope. Right? Well, that's kind of slick. Notice, and this is the part I would not have come up with, the tangent of angle 1 is equal to the same as its slope, AB over EB. The tangent of angle 2 is equal to CD over FD, which is its slope. And by the way, the previous step we said that those two, this part are equal. That can only happen one way if those two angles are congruent. That's why this one's slick. Okay?
What?
Hey, please stop. I know.
I'm just amazed by this.
I agree. It's pretty slick. So therefore, they're parallel. All right. That was the proof. What's the big takeaway?
That lines are parallel.
That if,
The slope are equal.
then they're parallel. Okay.
There are some smart people out there, man.
We're going to do the converse. The converse is done in a similar manner. Don't panic. So this is the converse. Instead of starting off with the slopes are equal, we're going to start off with that they're parallel.
Go backwards.
Prove, and we're just going to do the proof backwards. So we start off with the given. We're going to do it exactly the same way. In other words, I got angle 1 and angle 2. If they're parallel, then I know that the two angles are congruent because the two lines are parallel cut by this transversal. So angle 1 and angle 2 must be congruent. Well, if they are congruent, now we're going to make those triangle things. We make those two triangles, point E and point F. And then I can call out the tangent again, or the rise over the run. Either one is fine, right? If I call out the tangent, SOHCAHTOA, opposite over adjacent, that is the slope, right? Tangent is that slope. So therefore, I can say immediately that those two ratios are equal to each other. It makes a proportion. And by the way, that's the definition of slope, rise over run, and we're done. So the converse is true as well, too. Now we finally got something to write down. Here comes I said there are only two things today. Here's the first one. Make sure you write this down. Book of Truth, 13:3. Now, we can't say vertical lines, although vertical lines are parallel. We leave it to non-vertical lines. Why? Because remember, the slope is undefined for vertical lines. So if you have two non-vertical lines, they're parallel if and only if, that's the biconditional. That means it goes both ways, forward way and the converse. Two non-vertical lines are parallel if and only if their slopes are equal. So if the lines are parallel, their slopes are equal. If their slopes are equal, the two lines are parallel. That's your first takeaway. What does equal literally mean, Matt?
Exactly the same.
It's number. So if the slope of line 1 is 5, what's the slope of line 2 if they're parallel? If the slope of line 1 is -0.5, what's the slope of line 2? There's your first takeaway. And this is no different than algebra 1. We did this in algebra 1. If you have two parallel lines, their slopes are equal. If the slopes are equal, then the two lines are parallel. One of two things today. Parallel lines have equal slopes. If you have two lines or two, so you're going to see tonight, they're going to give you like quadrilaterals. So if two sides are parallel, well, then you probably have a trapezoid or a parallelogram. If all four sides or opposite sides are parallel, then you have a parallelogram. If just two sides are, I believe one of them is a trapezoid. One of them is seventh graders for their CMAS. They're seventh graders.
Why didn't we get
Why did we
food?
get food?
I didn't get food.
You're trying to get into college.
And
Work harder.
we need motivation.
We need food to be able to keep our brain cells alive.
I will post your comment to the, wow, it's snowing.
Oh my gosh. Change
Yeah,
the
It's
subject.
been snowing for like the
Yeah,
past
but-
5 hours.
Yeah,
It was raining when I came into work. It's not supposed to work that way.
it's Colorado.
I
What do you
know,
expect?
and it's May.
I know.
Yeah, do you remember last year we had a snow day?
Christmas is there. It is May, and this is happening. Come on, God. Why are you
It's actually springtime. I'm seeing what it says for field day.
There's a
next
year
week.
of Colorado.
Although it's useless to check because anything could happen.
I
If
swear,
it rains on field day, it will be good.
if the world
Rain is
just
okay.
stops
Yeah,
our
it's refreshing.
field day.
Cool.
Rain is awesome.
It just depends on the temperature.
True.
It's 40
Yeah.
degrees and rainy. That's kind of miserable.
If it's like hot and raining.
Yeah, that's fine.
Yeah, it's
All right.
One,
I said we're going to do two things. So the first one is if the lines are parallel, their slopes are equal. If their slopes are equal, then the two lines are parallel. The second thing is instead of parallel lines, we're going to have
perpendicular.
perpendicular lines.
Ah.
Anybody that hasn't looked in their book already from last year, do you remember what's the slopes of perpendicular lines?
No idea.
Well, clearly they're not equal to each other because they're not
Oh,
parallel.
it's the thing I was on the plate before that I didn't remember.
Okay.
Asking if we remember.
So you learned this last year, but you may or may not recall. This is used quite frequently in math. You know, you get to algebra 2 and pre-calculus, calculus, you'll use this about. All right. So two perpendicular lines. This is weird. You may not remember it from last year. It turns out that if you take, but for perpendicular lines, if you take their slopes and multiply them together, you always get -1. Weird. Two lines are parallel, you multiply them together, you can get any number. But if two lines are perpendicular, you always get -1 when you multiply your slopes. You probably remember this as not that. You might remember this as opposite reciprocals.
Oh,
And when you take opposite reciprocals, 2 over 1, if you multiply by 1 over 2, you get 1.
yeah.
And if you multiply opposite reciprocals, you don't get 1, you get -1. Ethan, any recall on that from last year? Okay. Okay, so that's what we're going to prove. This is once again an impossible thing without coordinate geometry. Notice there's no numbers, there's nothing. It's just that the two lines are
There are
perpendicular.
numbers.
So we throw the perpendicular lines on a coordinate plane and we see what happens, what we can do. Once again, it's a pretty slick proof. So here's how it's done. Step number 1, this symbol right here is the symbol for such that. Mathematicians are really lazy, right? We literally have a symbol for two words that we don't want to write. So this says construct V such that V is perpendicular to the x-axis. And we're going to label U and W. So here's what I'm doing. I'm going to go from this intersection right here where the two lines intersect, the red ones, drop it straight down perpendicularly to the x-axis. And I'm going to label that V, And I'm gonna label the other two pieces U and W. It should be, well, you can't really see it. I didn't, can you see that? What I did? I dropped straight down in blue to the x-axis. I labeled this piece V, this piece U, and no, I didn't do the thing, but it is on the, it is how we do the proof. Okay, everybody good?
Yes.
It's been a while since we've seen this, but we've seen this shape before. Do you remember when we saw this? Way back, I believe it's chapter 5, maybe it's chapter 8. Either chapter 5 or
That's
chapter 8.
what the angles and how they're adjacent to each other. It was like chapter 3 or 2.
When you have a line that comes from the perpendicular straight down, turns out you get three similar triangles. You have this small one, you have this medium one, and you got the big one, the big honking one. Okay? You got the small one, the medium one, and the big honking one. We proved that all three of those triangles are similar to one another. And then we got all of these, I don't know if you remember right, we got all of these ratios and proportions. Okay? But the key here is to remember that you pick a pattern and you stick with it. All three of those are right triangles. So you're going to have a short side, a medium side, and a hypotenuse. All of them are similar. So when you set up a proportion, you get to pick. You want to do hypotenuse over short side? Great. You want to do short side over medium side? Great. You can do any one you want, but when you say the similarity statement, or the ratio, when you set the two ratios equal to each other, you got to follow the same pattern. Okay? So we have three similar triangles, right? I'm going to use the same trick before. Notice if I have a triangle, you see the small triangle? Well, rise over run would be V over U. Rise over run would be V over U. For this one right here, that would be V over W. I can write their slopes just by the fact that I did some labeling there.
No.
So step number one, and there's a little bit of pre-thought for this. I just didn't write down a random one because I know where I'm going. I'm going to talk about slopes here in a second. Notice I said U over V. U over V is on the small triangle. You look at the small triangle, this unnamed side is the hypotenuse. U is the short side and V is the medium side. So I went short over medium. And then when I go to this one, short over medium. But yes, the reason why I picked those specific ones is because those are going to turn out to be the slope of those two lines. So this is way back chapter 8. Some person way smarter than me, figured this one out. Okay, cool. By the way, like I said, I picked those specific ones because those are the slopes. So slope of line 1 is V over U. The slope of line 2 is V over W. And notice I put a negative V over. Why did I do that? Why did I say negative V over W? Well, line 1, does it have a positive or negative slope? What's the difference between a negative and a positive slope? Ethan? All right, algebra 1. Are you walking up the mountain or are you going down the mountain? Line 1 is right here. Are you walking up the mountain or walking down the mountain?
It looks like it's walking.
Okay, we read from left to right. If I'm going from left to right, and this is the red is the mountain, am I going up the mountain or down the mountain? Up is positive. Line 2 is right here. Am I going up or down the mountain? That's how I explain it to kids, and usually most kids remember that one. If it goes from left to right in a downward direction, it's negative slope. From left to right, you got to remember you got to do it left to right though. From left to right, it goes in upward direction. It's positive slope. So the reason why I put a negative V over W because the slope is negative. This value V is going to be positive. This value W is going to be a positive value. They're distances. The slope is negative though, so that's why it's a negative V over W. That was probably the one step that you probably forget how to do. Okay, cool. Great. Now what? Well, what does it say? What am I trying to prove? If I multiply the two slopes together, I get, well, here are the two slopes. Let's multiply them together. This is slope of line 1. This is slope of line 2. Let's multiply them together. What do you get? You get a big mess. Negative V squared over what? UW? Well, that didn't help at all. So obviously there's a trick. One last trick. I'm going to take my pen, which I've already lost. I'm going to take my pen and circle this part, negative VW, and look at this part. What does this say right here? VW equals what? UV. Well, this says negative VW. So if I multiply both sides of this by -1, on this side I get negative VW is equal to, that's what I'm going to do. So that's the property of multiplying by -1 and a little bit of substitution. So instead of writing negative V over W, I'm going to write negative U over V. And now, maybe you can see what would happen when we multiply. Now what's going to happen when we multiply? Cancel, cancel, and you're left with -1, and we're done. Crazy slick. By the way, what the heck did we just prove?
Yes.
If
The two. Line, perpendicular.
got two perpendicular lines, guess what? The product of their slopes is -1. You're going to remember this as opposite reciprocals. You're going to remember this as opposite reciprocals. The book does a poor job of reminding you opposite reciprocals, and then they want you to use this. In order to use it, you're going to have to remember opposite reciprocals. If you two lines are perpendicular and you multiply them together, you get -1. Great. You will use that enough, not frequently, but enough. But you will have to make the slope of a line that's perpendicular plenty of times, and to do that, you need an opposite reciprocal. 13.4. I said 2 theorems, and that was the second one. When you actually flip your fingers through the pages here, if you notice, it's just 2 pages. I'm sorry, it's not even 2 pages. It's from here to here. It's not even a full page worth of material. And then they jump, okay, that's it. Class of Smith, let's do all the work now. They kind of leave off, they assume that you remembered all this from Algebra 1. And I've never seen anyone, honors or non-honors classes, remember this. I'll teach it like, okay, I kind of remember that. Some kids will definitely remember it, but I think they do a pretty poor job of practicing. We're going to do 2 examples, and then we'll open it up for classroom exercises and homework, just so that we make sure that we're solid on this. Ethan, opposite reciprocal, is that Greek to you, or that I know what that means?
Yeah.
Give me a fraction.
3 ones. Or
What's the opposite reciprocal?
1/3.
No. You left off one word there. Perfect. What's the opposite reciprocal?
Yeah.
Opposite reciprocal.
I was -1.
Because there's already a 1 under.
Opposite reciprocal.
So -1/4.
Opposite reciprocal.
1/4 over -.
Okay, one thing at a time. Opposite. What's the opposite of -4?
4.
Now I need a reciprocal, so flip it.
1/4.
Okay. So what's the opposite reciprocal of -4?
1 over. How is it a fraction?
Because everything is a fraction, or you can make everything into a fraction. So I would recommend for you is flip it first. Flip this whole thing. Flip the whole thing.
1 over -4.
And then what's the opposite of this?
Shebang.
Yeah, but the opposite of -4 is not -4.
4 over 1.
You just flipped it twice. Flip it once, and then if it's negative, it becomes positive. If it's positive, it becomes negative.
So it's just 1/4. then?
Perfect. You're going to need to do this a bunch more times. All right. So I said 2 examples. Unfortunately, these are the only 2 examples. Read it, Matt.
Determine the slope of a line parallel to a line that intersects S.
Ugh.
5 minus
Why do math teachers write complicated questions? All they're asking you to do is to find the slope of the line. The slope of the line is what? Parallel or perpendicular? What do we know about slopes of parallel lines?
Yes.
They're equal.
They're equal. So what's the slope of this line? Does it say? So guess what we have to do?
Find it.
How do we find it?
That's a great question.
How do you find the slope of a line if you're given 2 points?
Y2 minus
numbers.
Y1
Oh, well.
We go back to our friend, the slope formula. The slope formula is y2 minus y1 over x2 minus x. It's the change in x or change in y's over the change in x's. Change means subtract the two. Step number one, label. Label. Don't forget to label because you can screw this up really easy. Keep talking, Matt. Plug the numbers in.
Yes. So it's -1 minus 3.
This says y2.
3 minus +1.
So 3 plus 1 over.
-3 minus 5.
Okay. Which is you said it right.
4 over 3,
Which would reduce to
2 over 4.
Reduce to
1 over 2.
how would it?
1 over 2.
What?
Oh, I'm about as smart as a freaking dead dog.
How about just negative a half? Okay. If they ask you parallel tonight for homework, they're going to probably not tell you what the slope is. They're going to probably tell you some points.
That's exactly.
You're going to have to throw. In fact, they're even going to give you some shapes.
Correct.
And they're going to give you some of the points. The homework's a little bit challenging. A couple of them. Parallel lines, same slopes. I said 2 examples. All right, Wes, this one's yours. Read.
Determine the slope of the line perpendicular to the line that intersects S.
It's the same points, by the way. So what's the only difference here?
They're perpendicular.
Yeah, so what's the only difference that we're going to do? Wes, opposite reciprocals. Do you remember the slope of the previous one? This previous one, they were parallel. What did we get for the previous one for the answer? So what's the opposite reciprocal? Flip it first and then do the opposite.
It's
Flip.
just 2 over 1.
Just 2 over 1, which is just number. I would give you 100% credit for 2 over 1, but we would probably just write 2.
Okay.
All right. Hey, tonight for homework, it won't be that easy. It's the fact that they'll give you the same 2 points and then do parallel perpendicular. They're going to give you one or the other. So remember, if you're doing the whole thing by hand, you have to label first. Right? Make sure the labeling forces you to look when you do your plug and chug. If you don't label, you're going to make the mistake that Matt did, which is like reverse the numbers. But if you, I'm claiming if you label, there's less chance of you making a silly mistake. And oh, by the way, half of you will get to negative a half and like, woohoo, I got it. And you forget that you're doing perpendicular, you need the opposite reciprocal. So flip it first, and then if it's negative, it becomes positive. Positive becomes negative. Okay? So just plain old 2.
Negative sign on that first one.
No, I'm saying flip it first. Okay, I agree with you. Oh, yeah, I agree. I was just having you concentrate on the flipping part of it.
It's not wrong. You're
Right.
wrong.
Okay. By the way, the theorem says nothing about opposite reciprocals. It says if you take this slope and you multiply them together, you're supposed to get -1. Now, I'm not saying you got to do this. I'm just pointing out that when you multiply negative a half times 2, we do in fact get -1. They literally, there'll be nothing on homework where you have to do that. It's just you got to do the opposite reciprocal, which is weird that they don't point that out. All right, open up your books. If you don't already have them open up, page 536. 536. Cadence, you get to go first.
No.
Yes.
Let's go.
Well, you're going to pick one, you're going to do one. All right. This is question number 1, Cadence. Do 2 of them.
The answer is 2.
Find the slope of the line if L is,
It's E.
it says perpendicular. Given that L and N are perpendicular, find the slope of N if L is 2. So what's the slope of L? I'm sorry, what's the slope of N? I said it backwards.
4.
What do you know about perpendicular lines? Is it the same or is it opposite reciprocals? Opposite reciprocals. So given that L and N are perpendicular, if I give you one, I want opposite reciprocal.
So it'd be 2 over 1 and then
So the answer is
-1/2.
-1/2. Very good.
Whoa.
Go.
Uh-oh.
B. Go.
I got 4/5. Okay.
Are we doing parallel or perpendicular?
It's parallel, right?
Where do you see the word parallel?
Perpendicular.
Okay.
No, I was looking at this
So is parallel opposite reciprocals or equal? Is parallel opposite reciprocal or equal?
equal.
Okay, so we're doing opposite reciprocal. So opposite reciprocal.
-5/4.
Perfect. Connor? Opposite reciprocals. Flip it first and then give me the opposite. Is this a fraction? Yes or no?
Just to make sure it's the right L.
Is this a fraction? Yes or no? Hey, can I stop? So how do you make it a fraction? How do you make anything into a fraction? Connor, is 1/2 a fraction? So I don't need to do anything with that one. Is 1 a fraction? To turn anything into a fraction, you just put it over 1. Is that a fraction? So what are we going to do to make it a fraction? You just simply put it over 1. That's it. There's nothing challenging. Okay, to make an opposite reciprocal, you tell him, step 1, what do you do? Flip it. Flip it. No, let him do it. Flip it. And then, second step. So the final answer, Connor, would therefore be, you flipped it, and you said 1/-4, and then he said if it's negative, it becomes positive, so it's 1/4. Okay. Micah, you got this one. Undefined. So what's the slope of it? Of the perpendicular line?
Let's see if he's smart now.
How do we get undefined? How do we get
Is
undefined?
it horizontal?
Exactly.
No.
Which line has an undefined slope? You're no, but yes, that's the answer. What line has an undefined slope? If it's rise over run, what can we never have in the bottom?
0.
A 0. So what line has a run of 0? Like it doesn't go left to right. A vertical line. So what's perpendicular to a vertical line? So what's the slope of a horizontal line? Not 0/1 you might want to put, but just 0 is fine. That's the one you're gonna see that a lot of times, right?
I don't want to see it. I want to see anything.
All right, Micah, last one. This one's undefined.
Let's go.
So if 0 is a horizontal line, well, the one that would be perpendicular to be a vertical line, and that is undefined. All right.
It's not defined.
Okay, you go, Mike.
Ah.
All right. Chris, number 2. Parallel, perpendicular, or neither?
No.
If they're parallel, what do you know about their slopes? By 13.3. If they're, is it 13.2 or 13.3? 13.2, sorry. By 13.2, if they're parallel, what do you know about their slopes? Equal? This is number 2 in your question. Yeah, because we have to reduce that. What would that be reduced to?
You just didn't know because you did it 3.
Over.
No?
Yeah, they're equal. So this one is parallel. Seth? Parallel, perpendicular, neither. Number 3.
That's 1 and -1. It seems pretty easy on
13.3 says if you take their 2 slopes and you multiply them together and you get,
-1.
then they are perpendicular.
Yeah,
That's
yes.
negative.
They're perpendicular.
That's what I was gonna do.
Wes? Because when I multiply the 2 together, I get -1.
They do.
Are they parallel?
When I multiply the 2 together, I get -1.
Why not that?
If they're parallel, what do you know about their slopes? So therefore, what are we left with?
Neither.
I'm all good.
Neither.
It's
All right, Matt,
Same neither, dude.
number 5.
Who's that?
It's in your book.
Talking about? Number 5.
Parallel, perpendicular, neither.
Wait, with my gift.
Hey,
Parallel.
if they're parallel, that means they're equal.
Sorry, perpendicular.
They are perpendicular. Notice, a little bit harder to see, but they're opposite reciprocals of each other.
Take a checker back.
All right, Ethan.
You got this. I'm sure you.
got this. You got
I
this.
believe in you.
Are they equal? Are they equal? Are they equal?
Yes.
You can't flip them. Are they equal?
No, so then, no.
So they're either perpendicular or neither. If they're perpendicular, they're opposite reciprocals of each other. Are they opposite reciprocals of each other? You're asking like you're in Jeopardy. Yes. You don't give me your answer in the form of a question.
Essentially, it could be, but I'm not sure.
If you multiply 2 together and you get -1, they're perpendicular. That's the other part of 13.3. You multiply 2 together, do you get -1? They are perpendicular.
Yeah.
Look at you go.
Cadence.
Oh, you guys might be a little.
Are they perpendicular? Are they?
You tell me what they have to be perpendicular. You tell me.
Oh wait, hold on.
This is the one that will kick everybody's butt. Number 7.
They're neither.
They are neither. They certainly look like they're opposite reciprocals. But if you
they're not.
multiply them together, negative times a negative is a positive. You got a positive one, not negative. They love that one.
I'm gonna watch out for that one.
Connor, are those numbers the same or different?
Depends on your audio.
Hey, hold on. Same or different? I can't hear you. They're different. When we multiply these 2 together, do we get -1? Yes or no? So therefore, these are neither. Matt, you got the last one.
Okay,
Like a bird.
Say you're a bird.
Are they opposite reciprocals?
No,
So therefore, are they equal?
no.
Therefore, they are.
Horizontal.
What?
It's parallel, perpendicular, or neither.
Parallel.
Respectfully.
No.
If they're parallel, the numbers are the same.
The numbers are the same.
What?
Oh my god. Okay.
I don't think
We're going to go back to Ethan, who said, yeah, if you flip them. You can't flip them. Be careful what I'm saying. When you create a perpendicular line, yes, opposite reciprocals, you flip it. But if you're just looking at 2 numbers, the slopes of 2 lines, and you're comparing them, you can't flip them. They're either the same, they're multiplied together -1, opposite reciprocals, or they're neither.
Neither.
They are neither. All right, you guys are not giving me a confidence. Those that are paying attention got this. Ethan has this, but some of you were like, this is too easy for me to even pay attention. All right, last thing, I'll just use this blank sheet of paper. All right, Chris, pick one that you think is challenging for homework. What did I give you, 1 through 10 off?
Everything past 5. I mean,
All right,
Everything from 1 to 10.
pick
no,
one
through
that you
4
think is
okay.
challenging.
Anything past 4 is just
Oh gosh. Can we do like
the whole rest of the book.
I mean, if we go with number, if we go with
Let him pick, it's his choice.
Yeah, let him pick.
Number 87.
No.
Number 5, let's take a look at number 5. I gotta get a book.
Number 5.
Number
The kids I
5
have in my basement.
5 part
They
lab is
What page?
5 to 37.
All right, a little bit of silence here so we can do this one. This one's number 5. So you get this, clearly it could be a trapezoid, kind of looks like a trapezoid. Not sure, it's a trapezoid if ML is parallel to NP, right? And that's basically what this problem is about, is it a trapezoid or not? All right, so there's an A, B, C, D, and E. So it says, what is the slope of LM and MP? LM and PN, sorry, PN. So basically, they're trying to find the slopes of the 2 sides that we suspect are parallel. So this is back to the y2 minus y1 over x2 minus x1. So somebody give me L1, and you can do them in any order you want, whichever one be 0.1, 0.2. Give me the numbers
Negative.
in the slope formula. Minus. Look at the numbers.
Wait, what number are we?
Plus 2.
He's doing LM. We're doing the slope of LM. Minus what?
2.
Is it 2 or negative 2? It's 2. Over.
Negative 6.
You're just
Whoa, whoa,
saying
whoa, whoa,
random
whoa.
numbers.
Oh, wait, that's the different problem. Got negative 3.
Keep talking.
Oh, I'm stupid.
Minus.
This is 4.
Wait,
What is it?
M. Negative, negative 4.
Negative 4. All right. So that's going to give me what? Negative 3 over 4 minus 1 is 1. So I got a slope of what?
oh, okay.
Negative 3.
I got a negative slope of negative 3. Now,
I'm right.
hold on a second. I'm going to visualize. Look at side LM or ML. Does it look like that slope is negative?
Yeah.
Yeah.
It does. Okay, so that's just my just to check to make sure I didn't make a silly mistake. All right, let's do NP. Once again, give me the numbers. If we get negative 3 over 1, and then we know they're parallel.
2 minus
It's negative 2.
It's not negative unless you make it
Negative 2 minus 4. You see that?
Mm.
Over what?
minus 4. What?
Over what?
4 minus 4.
Where are you getting 4 minus 4?
4 minus 2.
You.
Wait.
X2 minus X1. X2 minus X1. Do you see where I'm getting these numbers from?
Yes.
Do you see why maybe labeling for some of you is going to be an important step?
2 and 4.
All right, what do we get for an answer here?
Negative.
Over, which reduces to,
Negative 3.
so are they parallel?
Simply outplayed.
So are they parallel? Yes, they're, well, it doesn't, that's not what A asks. It just says, what are the two slopes? We got negative 3 for both.
And then B
Part
and
B
Y.
says, why are they parallel? Because their slopes are equal, right? I'm going to skip C. You will find out that their slopes are not equal and they're not perpendicular.
They don't look like that at all.
And then E says, so what kind of quadrilateral is it?
Yes.
What?
It's a trapezoid.
It is a trapezoid. All right.
MNP.
There is number 5 done completely. I will point out 6 is probably the only one that will trip you up, and it's because S is not labeled. Everybody look at number 6. You notice that S is not labeled. They're going to ask you in part D. The rest of A, B, and C are fine. You'll be able to do that one. But D, they ask you to find the coordinates. So I will go ahead and give you the hint of how it's done.
Negative 1.
Think about this. You have, and it turns out to be a rectangle. You have a rectangle. If I'll do this in red here. If I can find my red pen. Oh my word. Oh, it's right here. If I make a right triangle right here, and it's a rectangle, that will be the same right triangle as
The one on the other side.
the one on the other side.
Oh my god.
So if we do the rise over the run here, which we can, it would be the same as right here. So what's the rise over the run on this side? Look at the numbers. What's the run?
The run is negative.
The run's got to be positive. The run would be,
0? Seriously, 0? No, copy 0.
look at the two coordinates. The run would be what? The X's or the Y's? It would be the X's.
Yeah.
So what would the run be? The run would be 5. You see where he's getting that from? What would the rise be? What would the rise be? It would also be 5. Where's he getting that from?
I was just looking at.
We're going from, look at the Y's. We're going from -8 to -3. You see that?
Oh, okay, yeah.
So on this side over here, they're going to give you coordinates. The slope is going to be exactly the same. So you're going to do what? You're going to go up and you're going to go over. Now you just got to figure out what that point would be. They tell you what this point is right here. So it says up 5, right 5. All right. That's the only one that I thought was challenging. Okay, that's it. Done. Was that 5 minutes early?
I sure hope so.
You're on time.
Yeah, you're literally on time.
No.
I live like a minute.
No, we're out of here. Go. Hey, don't go to your lockers. Don't make noise in the hallway.
All right, I'll make sure it's
Do not go. They're going to be watching, so don't go to your lockers.
Scream something out.
Scream,
Don't touch my keys.
Who's ready to be judged on this for us? I am.
I don't think she's gonna bash us as hard as
Oh, yeah. Miss Newbern scored.
Miss Newburn's gonna bash us.
Oh, yeah.
Hey,
I don't wanna go.
She already did it online, so
Yeah.
there's nothing
It's
like.
gonna be worse.
I did ours.
She's
I didn't
gonna
learn
look
to.
like.
She's gonna
Let us have your funeral, like from the dead.
I didn't do like.
At least about not academic stuff. Well, he was a nice kid. Never did any work, but he was a nice kid. But I had to take 2 weeks off in chemistry during quarantine.
Actually, I did all my work, I just failed. What happened? Except for my lab packet and a couple worksheets I did. the rest.
You did show up every day for math class, though. I'll give you that. All right, Jen, are you live? No, Jenna's not live. All you unlive people, that's weird. Have a great day. I'll see you tomorrow.